This is the Mapping Toolbox interface when the software is opened. Underneath the software name and version, you will find a menu bar with 5 options. As you can see, the edit and view options are currently grayed out, and this is because there's no image imported for the software to analyze. You can enable these options by clicking on File in the menu bar and then Open Image. The user can browse to the folder containing the desired image. The File menu contains basic file functions. The first option is Open Image. As seen just now, this opens an image with any size in the display panel. The next option is Save Image. This saves an image shown in the display panel with a default size of 1280 by 1024 pixels. The next option is Import.map. This function imports all information contained in a map file such as positions, boundaries, and references in the display panel. The next option is Create.map. This function creates a map file containing all positions, boundaries, and references shown in the display panel. It also takes a snapshot image of the display panel and saves it as a .jpg extension. The last option is Exit. This function closes the Mapping Toolbox software after user confirmation. The Edit menu contains basic editing functions such as setting grid, adding positions and boundaries, deleting positions and boundaries, adding references, calibrating values for the reference indicators, and image transformation. For now, I will delete all predefined boundaries and positions to show you how these functions work from scratch. To delete all existing positions, boundaries, and references, right-click in the display panel and click these options. Now let's take a look at each individual option in the Edit menu. The first option is a grid function. When selected, a pop-up window will open. This allows the user to configure the grid of snapping dots according to either an image-centered square configuration or table configuration. In the square configuration, the user must specify a size in pixels which can be set from 10 to 200. This is the distance between each grid point on the XY plane in pixels. In the table configuration, the user must specify the number of columns and number of rows which can be set from 2 to 50, extended on the full size of the image. The grid type and size will vary based on the objectives of your study. For now, I will keep a square grid with a size of 75 pixels for this demonstration. For adding positions and boundaries, which are the next two options, it is important that the user selects the appropriate subsurface from the Subsurface ID drop-down list. You can also edit the subsurface name by clicking in the provided field. In this example, the map file imported earlier already had the subsurfaces predefined. Since this image is of a femoral cartilage of a rat, these subsurfaces are the lateral and medial condyles. Failure to select the appropriate subsurface will lead to incorrect assigning of position IDs and boundaries. I will first add positions to the lateral condyle of the sample, making sure that this subsurface is selected. Click Add Positions from the Edit menu. This function allows the user to define positions of interest on the sample. Click at each location of interest in the display panel and a position marker will be added. To complete this task faster, when the snapping grid points shown as gray dots are toggled on in the display panel, click and hold down the Control key and click the left mouse button. This will change the selection cursor into a cross. Now the position markers will be added to the snapping grid points as the user hovers over them in the display panel. To terminate this command, simply left-click again and the selection cursor will reappear. It is recommended to add positions in the same order that the measurements will be taken. Ideally, the user should define all points on all subsurfaces to achieve mapping of the entire sample surface, but in this case, I will focus on the lateral condyle subsurface only. The next option is to add boundary. This allows the user to define the boundary of subsurfaces of the sample. Once again, I will keep the lateral condyle selected as I will add boundary to this subsurface. In this case, I will turn off the grid from the View menu beside the Edit menu. This will prevent the boundary points to snap to the grid and will result in a more smooth outline when defining the boundary. The next option is Delete Position. This function allows the user to delete position that is not overlaid on a location of interest on the sample. Click at each location of interest in the display panel and a position marker will be removed. To complete this task faster, when the snapping grid points shown as gray dots are toggled on in the display panel, click and hold down the Control key and click the left mouse button. Now the position markers will be removed as the user hovers over the grid points in the display panel. To terminate this command, simply left-click again and the selection cursor will reappear. The next option is Delete Boundary. This function allows the user to delete boundary that is not overlaid on a boundary of the sample. Click on a boundary point in the display panel and as a result, the closed contour will be reshaped. The next option is Reference 1 Red. If required, this function allows adding a first reference marker. Click in the display panel where the first reference is marked on the sample and a red reference indicator will appear. At each click, the red indicator will relocate. The next option is Reference 2 Blue. If required, this function allows adding a second reference marker. Click in the display panel where the second reference is marked on the sample and a blue reference indicator will appear. Once again, at each click, the blue indicator will relocate. Both of these reference markers are used to calibrate the sample, which is the next option in the Edit menu. The calibration function allows the user to assign metric coordinates to references 1 and 2. When Mach 1 metric coordinates are entered, scan-X and scan-Y characterizations are automatically generated in the scaled position box shown. This function is applicable only when reference 1 and 2 markers are defined in the display panel and when all 4 fields are different from 0. Make sure to click away from the field to update the table. If needed, the scan functions may also be exported to file and copied to clipboard. The next option is a transform function. If required, this function allows the user to transform an image to fit the boundaries of an imported map file, which is usually a positioning template. This can be achieved with the following steps. Open an image to be transformed with Open Image. Import a map file containing the desired boundaries, which is usually a previously saved positioning template. In the positioning template field, you will now see the file name.map of the last surface positioning template imported or used to position the sample in the display panel. Click on Edit, then Transform, and a window will appear. The user can transform the image using translation, rotation, and scale options to fit the image to the boundaries of the imported positioning template. For the translation transformation, the options are up, down, right, and left. An appropriate translating factor can be inputted in the shown field to control the precision of translation. For the rotation transformation, the options are either counterclockwise or clockwise. Once again, an appropriate rotational factor can be inputted in the shown field to control the precision of rotation. The scale option is used to scale the image with an appropriate scaling factor. The Reset button next to the Scale button removes all transformations and restores the initial image settings when imported. The mouse control allows the user to apply mouse-controlled image transformations. This can be done by first selecting the type of transformation from the drop-down list. Press Ctrl and left mouse button in the display panel to start the transformation, and left mouse button to stop the transformation. For example, if I want to translate the image with the mouse, I should select Translation, then press Ctrl and left click and you will see the selection cursor change to crossed arrows. Then apply the desired translations to your image. Left click again to terminate the command and the selection cursor will reappear. To change the size of the crosshair shown at the center of the image, enter a numerical value in pixels in the provided field. Click on the small box to the right of this field to change the crosshair color. The next option in the menu bar is View. The View menu provides the ability to toggle on and off the grid as seen before, as well as Positions ID. When the grid feature is checked, it toggles on a grid of snapping dots in the display panel defined by the user. The use of this feature will vary based on user preference and objectives of your study. For example, it can be turned on when adding positions for proper aligning of points and turned off when adding boundaries to a subsurface. Similarly, when Positions ID is checked, this will display the position number or ID at the bottom right of each position marker. These labels are consecutive numbers starting from 1 for the first position added in each subsurface. The first camera option is Start. This starts the live camera feed in the display panel. The next option is Stop. This stops the live camera feed. The next camera option is Settings. Once selected, a window will open where the user can adjust the camera settings either by using the slider bar or inputting a value in the field provided. The first camera setting is exposure time. This is the duration of time in microseconds that the digital sensor in the camera is exposed to light. This setting has limits from 59 to 99,900 microseconds. The next setting is gain in decibels and has limits from 0 to 12. The first balance ratio controls the red balance and the second controls the blue balance. Both have limits from 0 to 16. For automatic adjustment of the white balance, click on Auto. The software will take a few seconds to define the new parameters while briefly disabling the reset button. The reset button restores the initial camera settings. The last camera option is Select. This is used to select the appropriate camera and projects its live feed in the display panel. Help menu contains basic help functions such as information about the user manual and camera. Click on the User Manual button to access a PDF file of this software user manual. To view this file, the Adobe Reader must be installed on your computer. The second help option is About. This contains information about the installed software and camera. Here is an example of a rat cartilage with calibrated image of the sample surface with boundaries, positions, and references defined.